Next up, we have Brian Day. He'll be presenting NASA Solar System Treks, New Worlds, New Portals, New Updates.
Thank you very much for being here on behalf of myself, Brian Day, my co-lead, Emily Law, and our development team at NASA JPL. As Mark Robinson said earlier today, the old LMMP project is alive and well in the form of the Solar System Treks now, a family of online data visualization and analysis portals accessible through trek.nasa.gov. And these represent a family of portals that are covering an expanding number of worlds throughout our solar system. Over the past year, we've had a number of new releases, new additions. I'd like to summarize them today. We've been putting a lot of effort into our DEM and Orthophoto Mosaic pipeline. We've had them busy generating NAC mosaics and NAC stereo pair DEMs specifically for the Artemis program and focusing on LDEP. You combine those with the tools available and you're able to do some fairly...
Sorry, Brian. Yes. I think what we thought was your slide is actually we're seeing your Corel Paint Shop Pro program.
That is not what we should be seeing. Okay, so let's escape again. And I'm going to stop sharing and I'm going to try sharing again. And it should... Okay, I'm just going to share my screen rather than try to share the app. Okay, are you seeing a slide?
Yes, I'm actually seeing a slide this time. It's in presenter mode.
Okay, how about now?
Good.
Okay, so again, DEM and Orthophoto Mosaic pipeline. Combine that with tools. You can do fairly sophisticated site analysis. These are the basic tools available to anyone who comes into trek.nasa.gov. You've got distance, elevation profile, etc. But if you're a researcher, you can go through the sign-in menu and get account-level access that will provide you with more computing-intensive tools. Those include machine learning-based crater detection, rock detection, subsetting, slope analysis, surface lighting, surface electrostatic potential analysis that's based on the work we heard about earlier from Bill Farrell. Let's take a look at a few quick examples here. In terms of the crater detection, we can employ image processing and convolutional neural network to find crater hazards. This will generate a hazard heat map, color-coded, a geotiff of craters labeled with bounding boxes, as well as a text file that includes locations by lat long, depths, diameters, and associated confidence values. Similarly, we have rock detection that will generate a color-coded density image of the NAC strip, a JPEG of rocks labeled with bounding boxes, and text files with coordinates. You can also do slope analyses, so custom slope analyses. All of the examples you've seen here have been for the Locus Mortis area for the Astrobotic Mission 1 landing site. So again, we are working with LDEP. But as Ben Bussey mentioned yesterday, there are other areas that they are looking at and we are working with them on. So within Mare Crisium, there's the candidate Picard landing site. You can see the outlines of our NAC mosaic that are overlaid on top of the wider angle WAC mosaic. The inset shows a boulder field along a Mare Wrinkle Ridge. Also within Mare Crisium, we have a new mosaic, NAC mosaic, we're working on for the Horseshoe landing site. Again, we're going to be doing full site analyses for these. In addition, we have a bunch of new data products. These include the Chang'E 2 Global Mosaic and DEM. These are really cool additional products that give some nice intermediate areas between WAC and NAC. This is the Chang'E 2 global mosaic is the highest resolution full coverage global mosaic of the moon. A number of other tools are under development. Line of sight calculation will provide communications planning capabilities. The path tool, initial implementation for traverse planning will be based on slope constraints. We're working with Simone Dell'Agnello, our Survey's Italian partnership, on laser reflector geometry, and Valentin Bickel on rockfall detection. That's something that came out of originally David Kring's student teams, and Valentin was part of that. But now this is something where we're working with Treks and geodes, possibility of looking at integrating this into the probabilistic seismic hazard analysis that you just heard about from Lisa. Now on Mars, we have just released a new beta version of Mars Trek that includes improved user interface and search capabilities. It also includes more advanced tools, including the crater detection, rock detection, subsetting, and slope analysis.
Ryan, you're at 10 minutes.
Okay, CT, how many minutes?
You're at 10 minutes, so we're going into the question session. I have the timer wrong.
Okay, so we'll go quick. We have Mercury Trek here. We've enhanced that. We've added Japanese interface. We've added new data products. Ryugu Trek. We're planning to release this next week at JPGU, working with JAXA. Again, we have a Japanese interface. We focus on named features as well as areas of surface operation. We're working with OSIRIS-REx on the Bennu Trek, and that's going to be released sometime this summer. Features areas that are key for the natural feature tracking that you heard about from Kevin Walsh yesterday, as well as the candidate landing sites. And I am done.
All right. Thank you, Brian.